Hello, hello, friends. Something a little different today. This is No Solutions Killer by zetamath. Your goal is to prove that this puzzle has no solutions. What? Let's get started. I don't really have a goal in mind or like a strategy in mind, so I think I might just like try to solve. I have a bunch of these. Powfly was like, hey, have you ever heard of this? And I said no. And so Powfly got a bunch of puzzles that are like the same idea where like you have to prove that there's no solution. And so I have a list of these I'm going to go through. I don't really have a strategy in mind. I think I'm just going to try to solve them as I normally would until I get to a, hey, this doesn't work type of thing. No Solutions Killer by zetamath. Your goal is to prove that this puzzle has no solutions. Normal Sudoku rules apply. Healer cages. Digits cannot repeat in a cage. Okay. So we have one cage. Okay. Okay, this like should be easy then, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Why would this not be solvable? So digits can't repeat in a cage. Maybe it's something about, I don't have a sum for this. So is there something about how, hey, these can't be 9 individual digits? I think this would have come in handy for the puzzle that I posted yesterday. And maybe I should have done this first. Let's make these all different colors. And then I don't want to change pages on the color thing. So if this were to be 9 different numbers, because it just can't repeat in a cage. So we could do stuff like, where would red go in here? Red would have to go up here. So one of these is going to be red. Because red can't go here and red can't go here. Where would orange go? Orange would also have to go up here. Okay. Let's see. But then, oh, well, there it is. There it is, actually. These 4 need to go in here somewhere. None of them can go here, and they also can't go here, so these 4 digits would be stuck going up here. That's why it's not solvable. There you go! Oh, I was so intimidated going into this. Oh, I see. That's why there's a big list of these. These are probably going to get harder. Oh, no. Okay, final answer for this one. It's because these 4 cells would have nowhere to go in here. They would all have to be crammed in here. All right, final answer. Let me get the next one on the list. Oh my gosh. Oh my gosh. Okay, copy link, post, paste, words. Gosh, I'm good at words. Some of my keys on my number pad aren't working today. What's up with that? No Solutions, Arrow Kropki by Philip Bloom, aka Glum Hippo. Your goal is to prove that this puzzle has no solutions. Normal Sudoku rules apply. The digit in the circle is equal to the sum of the digits on the attached arrow. Kropki, digits separated by a black dot, have a 1-to-2 ratio. This puzzle does not have solution checking. Oh yeah, my number pad isn't working. That's neat. Good thing I'm not doing actual Sudoku today. This puzzle has no solutions. Okay, so why, if this has a 1-to-2 ratio and it's also an arrow, why does this not work? Okay. They're just separated by a black dot, have a 1-to-2 ratio. Oh, so that would be because if this has a 1-to-2 ratio, then there's no way that this digit could, let's make them different colors so I can talk about them. There's no way that red could be less than yellow. So red would have to be the 2 ratio and yellow would have to be the 1 of the ratio. But then orange would have to be the same as yellow. In order for orange and yellow to sum to red, orange and yellow would have to be the same if we're following the Kropki dot as well. Nice. Oh my gosh. Wait, these are good for going through. I can't do 2 things at once. I don't know what I'm doing. These are good practice for like how to solve regular puzzles. Thinking about what stuff doesn't work. Oh, this is so smart. No Solution, Renban Palindrome by Wisteria Fall. Your goal is to prove that this puzzle has no solution. Normal Sudoku rules apply. Renban, digits on the thicker purple line form a set of non-repeating consecutive digits in any order. Palindrome, digits filled into the thinner gray line. I can read. Read the same forwards and backwards. Okay, so this is a Renban, and this is a palindrome. So this number is the same as this number. These two are also the same. These two are the same. So I like palindrome lines in this shape because it just screams that, hey, red, orange, and yellow also have to go up here. Okay, this is a Renban, non-repeating consecutive digits in any order. So, whatever digits go here, if this is blue, green, and pink, then blue, green, and pink need to go in here somewhere. They can't go here, they can't go here, so blue, green, and pink are going to go here in some order. And blue, green, and pink can't go here, and they can't go here because this is red, orange, and yellow. So blue, green, and pink would need to go here, but I can't have repeating digits on this line. So that's broken. So that's why this one doesn't work. Very cool. Very cool. Next puzzle. Oh, I lost my place. Let's look at the, let's be smart and look at the URL. Okay, this one is No Solutions, Arrow Numbered Rooms by Malrog. Your goal is to prove that this puzzle has no solutions. Normal Sudoku rules apply. Arrow, the digit in the circle is equal to the sum of the digits on the attached arrow. Okay, so these three cells must sum to be this. Numbered rooms, clues outside the grid indicate the digit which has to be placed in the nth cell in the corresponding direction, where n is the digit placed in the first cell in that direction. So if this was an 8, then that would mean 3 goes over here. For example, so why do these not work together? Well, the 3's crossing each other is very interesting. So these can't both be a number between 1, 2, and 3, because that would put 3 twice in the same box. Like if this was a 1 and this was a 2, well, 1 would already be an issue. Because I would also have to put 3 in here. Okay, so let's start there, actually. These can't be 1s because that would mean 3 has to go in the same cell. Numbered rooms don't work with 1s. If these were 2s, that would mean that 3 goes here. So one of these could be a 2. If this was a 2 and 3 goes here, that's fine. Except we also have a numbered room up here where whatever this is talking about where the placement of the 3 is. This would also have to be a 2 in order for that to work. So neither one of these can be a 2 either. What if it was a 3? If it was a 3, that would mean 3 goes here. So 3 is not going to work even alone. Even only looking at one of these, 3 won't work because that talks about the placement of the 3 and it would have to index its own cell and that doesn't work. A 4 here would mean that 3 goes all the way out here. I can't, which is fine. I can't repeat digits in a region, so this would have to be higher than a 4, meaning this would have to be a 5 at a minimum, putting 3 way out here, which is fine. But then this arrow is broken because this is already 9, and the lowest this could be is a 1, which would make this a 10, which is not going to work. So that's why this one's broken. Very nice. Very cool. Oh my gosh. Neat. Okay, so wait, in one sentence, or 2 sentences maybe. The minimum that these cells could be with the number rooms is 4 and 5, which breaks the arrow. Nice. Nice. Gosh, these are cool. Copy text. Copy text. Puzzle not found. Uh-oh. Did I copy it wrong? Nice. Okay. No Solutions, Entropic Lines, Global Entropy by Raumplaner. Your goal is to prove that this puzzle has no solutions. Normal Sudoku rules apply. Entropic line. Any 3 adjacent digits along a peach line are from one each of low, medium, and high digits. Global entropy also. Each 2x2 of cells in the grid must contain at least one each of low, medium, and high digits. Perfect. I haven't done entropy for a while. I really like entropy puzzles. I haven't done those for a while. So this is an entropic line where we're going to have a pattern. Red, orange, yellow, red, orange, yellow, red, orange, yellow. I don't know what order these are in. It might be low, medium, high, low, medium, high, low. It could be medium, high, low, medium, high, low, medium. Something like that, but all the red are the same, the orange are the same, and the yellow are the same. I also know that in a region, I need 3 of each color, 3 of each entropy. So these are going to be 1 orange and 1 yellow. So for this 2x2 area, I need a yellow. So this has to be yellow, but then that breaks this 2x2 area. I wouldn't have an orange for this 2x2 area. So this cell, and then this is fine. These 2x2 areas are fine, but this cell is what breaks it. I need this to be both orange and yellow because of this shape. And I can't do that, so the puzzle's broken. Nice. Oh, getting quicker. I'm understanding it, but that also means these are just gonna get harder. That just means these are gonna get harder. No Solutions Arrows by Emphyrio. Emphyrio? Oh, that's a cool name. Your goal is to prove that this puzzle has no solutions. Normal Sudoku rules apply. Arrows, the digit in the circle is equal to the sum of the digits in the attached arrow. Perfect. So, I have 3 arrows here. These 2 cells sum to be this number. These 2 cells sum to be this number. And these 2 cells sum to be this number. Let's look at... These have to be 3 different numbers. These have to be 6 different numbers. What is the minimum that 6 different numbers can be? 1 plus 2 plus 3 plus 4 plus 5 plus 6. 21. I could have 3 numbers to sum to 21. That's fine. 9 and 8 already gets me to 17. I also need... What's the minimum these could be? 3. This could be 1, 2, and this could be 3. Okay, that's fine. Maybe... Where does this digit go in here? It can't go here, so it would have to be on the line. So this would have to be small enough to be on a line of an arrow. And this digit as well. Okay, so both of these digits would have to be small enough to be over here. They can't go on their own arrow, so red would have to go in here somewhere. Orange would have to go in here somewhere. At least one of them is going to be on this line. How can I explain this? So red can't be on here, but if red is on here, like if this is red and this is yellow, orange is bigger than red and wouldn't be able to be on this line. So orange would have to be on this line somewhere. Maybe this is orange and this is green. I guess I should technically do it like this. So that would mean I would need a new number for here. 2 new numbers that I haven't used yet. Okay, so what does this mean? If I put digits in here, what's the smallest? Okay, so orange is bigger than red. If this is like 1, 2, that's the smallest this could be. That would make this a 3. So the smallest this could be would be 3, 4, which makes this a 7. But, okay, I see. We're going in a circle here. This can't be a 1 or a 2. This would have to be smaller. I think I might have said backwards earlier about orange and red. Red is smaller than orange is what I meant to say, if I didn't. The smallest this could be is a 3. I should look at this way, meaning this would be 1, 2. Because orange is bigger than red. Okay, so one of these is a 3 then. Let's do that. One of these is a 3. The minimum this would be 3, 4, making this a 7. There you go. Which means 7 is included in this. But the smallest number I could add to it is a 5. That's not a proof because there's other combinations available. Not a proof I'm satisfied with. And that was also just a what if thing. What if red and orange go here? How do I prove it? I need to prove it. What if red and orange are on here? So, I mean, like, this is 1, 2, and this is 3, 4. Bad. I don't like that. I don't want to say what if. I don't want to say what if. How do I prove it? This is a digit and this is a digit. This needs to go in here somewhere. So one of these is red. Orange needs to go in here somewhere. One of these is orange. Hmm. Oh, I was just talking about how these were getting easier. Am I overthinking this? I liked what I said earlier about the minimum this could be is 21, but it's fine if these sum to 21. If these sum to 21, then this... Ooh, there's something. Oh, if I think about sums. Okay, so the sum of these 6 cells is the same sum as these 3 cells. Can I do something with that? The sum of these cells, if I think math, red is equal to 45 minus whatever this is. 2. Let's make an equation. Red is equal to 45 minus 2 yellow plus orange plus green. Parentheses. We're on to something there for sure. Okay, so it's been 2 days since I recorded that, and I'm going through and editing the video now, and after this point that you just saw, I spent another 20 minutes like going in circles on this, because nothing, I was coming up with ways to break it, but nothing felt like a definitive proof that I could fit into like 1 or 2 sentences of like why it doesn't work. It was just like every example I came up with wouldn't work, and that didn't feel right, but I think I see it now. So, if this, let's do this. If this section sums to 45, right? And also this section sums to 45. And we also know that these are the same numbers wherever they are. They're going to contain the same set of numbers, right? So if I make this red and this blue, these are going to contain the same numbers. These are both going to sum to 45. So we can kind of cancel some things out also. If each of these are the same 3 numbers, then these 6 red cells and these 6 blue cells are the same. We also can say that these 2 cells, these 2 red cells are the same as this 1 blue cell, so we can cancel those out. These 2 red cells are the same as this 1 blue cell. So now we're left with these 2 red cells sum to these 4 blue cells, which would be fine, except that they also have to sum to be this 1 green cell because of the way the arrows work. So I would need 4 different cells to have the same sum as this 1 individual green cell, which is not going to work, because the minimum these could now be is 1, 2, 3, 4, which is 10. So I want to say that a second time just to make sure it works, because it is 1 a.m. when I'm looking at this. So if you make all of this red and all of this, all of this blue, these are going to have the same sum. Hi, Loba. She's cheering me on. That's how I'm thinking about it. So these cancel each other out. So these 6 cells have the same sum as these 6 cells. These 2 cells have the same sum as this 1 cell because of the arrow, so we cancel them out. These 2 cells have the same sum as this 1 cell because of the arrow, so we cancel them out. And now we're stuck with these 4 cells have the same sum as these 2 cells and also this 1 cell, which that is why it won't work. I think that's it. I think that's it. I might leave the rest of it in the video anyways and not cut it, because I think I came up with a lot of good points, even though it ended up not being right. But also highly recommend you just stop watching here, because the next 20 minutes is just me rambling and going in circles about trying to figure out what to do. But yeah, I think I got it. I think that's it. 33.22 total spent on this puzzle. Oh my gosh.